am back with the new introduction to IB Chemistry. As you all know, IB Chemistry has made new updates to its curriculum, so I thought I should be making videos that takes into account the upcoming changes. I took a look at the new chemistry guide and noticed that the changes are pretty big. In this video, I want to go over these changes and show you what changes have been made. Let's start. This is the new IB Chemistry syllabus. This new curriculum will be first assessed in year 2025. And as you can see, the curriculum is mainly divided into two sections, structure and reactivity. Each of these concepts will be further divided into topics and subtopics, covering most of what was covered in the previous curriculum. Let's take a brief look at the previous curriculum. This is the old curriculum. When you compare this to the new curriculum, you can see that there has been great reduction in content. Now, I will highlight a few more changes. First, no more option topics to study. Most of the content has been removed, and a few has been merged with the new core syllabus. Next, the internal assessment, or otherwise known as the IA, has been renamed to the scientific investigation. Further on in the video, I will specifically talk about this investigation and how it differs from the previous IA. Lastly, the Group 4 project has been renamed to Collaborative Sciences Project. I believe that this collaborative science project, in a sense, is similar to the Group 4 project. This project will still be an interdisciplinary sciences project that will help students explore real-world problems through ranges of subjects in the sciences group. Now, let's take a look at the syllabus roadmap provided by IB. Structure, which is the first section, will talk about the nature of matter from simple to complex forms. And this section is divided into topics and subtopics. The second section, reactivity, will discuss how and why chemical reactions take place. Again, this section will be further divided into topics and subtopics. At last, these sections all come together under the idea that structure determines reactivity, which in turn transforms structure. In studying IB chemistry, students will need to acquire skills and techniques throughout the course. These skills and techniques will be referred as tools. Tools will encompass experimental techniques, technology, and mathematics. These tools will help support the application and development of the inquiry process in the delivery of the chemistry course. The inquiry process encompasses exploring and designing, collection and processing data, and concluding and evaluating. The skills of individual students will be assessed by the internal and external assessment. Okay, this is the assessment outline for the new syllabus. Let's first look at SL. The external assessment weighs 80% of your entire grade, so this assessment is quite important. It consists of Paper 1 and Paper 2, which each weighs 36% and 44%. Paper 1 is then divided into two sections, Paper 1A and Paper 1B. Paper 1A is comprised of 30 multiple choice questions on standard level material. And Paper 1B is comprised of data-based questions and questions on experimental work, such as labs. You will be able to use the calculator and chemistry data booklet for Paper 1. Paper 2 is made up of short answer and extended response questions on standard level material. Again, you will be able to use the calculator and chemistry data booklet for this paper as well. Much is similar for HL, only that Paper 1A will have 40 instead of 30 multiple choice questions. And the questions will be based on both standard and higher level material. HL students will possibly have more questions for Paper 1B as well. Because of this, students will have an additional 30 minutes compared to SL students. Now let's look at the internal assessment. Both SL and HL students will be participating in the internal assessment, which makes up 20% of their entire grade. The internal assessment is now called as the scientific investigation. IB refers to the scientific investigation as an open-ended task that requires students to formulate their own research question and gather and analyze data to find answers to their own research question. So, the scientific data is similar to a research paper with a maximum overall word count of 3,000 words. Looking at the internal assessment criteria, you can see that it is composed of 4 criterions: research design, data analysis, conclusion, and evaluation. Each criterion weighs 25%. Let's look at each criterion in detail. First, research design. The criterion research design assesses the extent to which students effectively communicate the methodology used to address the research question. So, to get a high score in this criterion, first, students need to have a clear, specific, and appropriate research question. Second, students need to clearly state their methodological considerations on how they're going to collect relevant and sufficient data that matches their research question. And I want to highlight that the descriptions of the methodology needs to be clear and in detail so that the investigation can be reproduced by a third party. Next, data analysis. This criterion assesses the extent to which the student's report provides evidence that the student has recorded, processed, and presented the data in ways that are relevant to the research question. Technically, students need to clearly state how they gathered and analyzed data relevant to their research question. To get a high mark, students need to be precise and clear in their presentation of the recording and processing of data. And also, students need to show appropriate consideration of uncertainties that are included in the data they have gathered. Lastly, students need to show that they have accurately and appropriately analyzed data that is relevant to addressing the research question. The next criterion is conclusion. This criterion assesses the extent to which students successfully answers their research question regarding their analysis and the accepted scientific context. To get a high mark, students need to present a conclusion that is, again, relevant to the research question and is consistent with the analysis. Also, the conclusion should be justified through relevant comparison to the accepted scientific context. The last criterion is evaluation. This criterion assesses the extent to which the student's report provides evidence of evaluation of the investigation methodology and has suggested improvements. To get a high mark, students need to include what kinds of weaknesses or limitations that their research holds. Also, students should include realistic improvements of these weaknesses and limitations. I hope this video gave everyone a clear understanding about the changes that are going to happen in IB Chemistry. I will be uploading new videos according to the IB Chemistry's new syllabus soon, so stay tuned.